So far in this unit, we've learned several ways to represent motion, including the written description of the motion, position versus time graphs, and velocity versus time graphs. This video will introduce you to a final representation of motion, which is using equations or calculations. So when it comes to the calculations that we'll do in this unit, we have two equations. The first equation is for average speed. We'll use an S to represent speed, a D for distance, and a T for time. So speed, as we defined it, is the distance divided by the time. Our other quantity is average velocity. And in this case, the average velocity is the displacement divided by the time, or delta x over delta t. You'll notice both the velocity and displacement are vectors. And remember, that means we need to pay attention to direction as we're calculating those quantities. So let's take a look at an example problem. Go ahead and pause the video for a moment to read through the entire problem, and then unpause and resume that video once you've read through. In our first question, we're looking for Monica's average velocity. It specifies that we want it in kilometers per hour, and it's only while traveling from Cincinnati to Indianapolis. Every time we're doing a calculation, we always want to start by writing out our basic equation. This basic equation, in this case, being the average velocity is the displacement over time. Then we want to include our work for plugging in numbers: 168 kilometers from Cincinnati to Indianapolis, and 110 minutes. Now the question specifically asks for this in kilometers per hour, so we're going to convert those minutes to hours. So knowing that there are 60 minutes in an hour, we end up with 1.83 hours. In physics, you never want to leave your answer in a fraction. You always want it to be in decimal form. And so using our calculator, we can determine that this is 91.6 kilometers per hour. Since average velocity is a vector, we also must include a direction unless we are told otherwise. And so in this case, it says that we're assuming that she travels west along I-74, and so west would be my direction there. Moving on to part B. This asks for total displacement. So not just from Cincinnati to Indianapolis, but throughout the entire trip. That includes two portions of motion, the 168 kilometers and then the 388 kilometers. So to find the total displacement, we'll add the two together to get 556 kilometers. And again, we need a direction because displacement is also a vector. So we add that word west onto the end. For part C, it's asking for the average velocity for the entire trip. Again, going from Cincinnati to St. Louis. Average velocity is defined as being the displacement divided by the time. And so if we're doing an average velocity for a trip that includes multiple different velocities or multiple different portions of the motion, we want to go back to that equation and use the total displacement divided by the total time. This is really important here. Average velocity is not just the average of two velocities. Or really, I should say it's not the average of two or more velocities. To find average velocity, you must always do the displacement divided by the time. So in this case, we know that the total displacement is 556 kilometers. And in the denominator, you see that I've added together the three amounts of time: the 110 minutes from Cincinnati to Indianapolis, the 45 minutes spent eating lunch in Indianapolis. Even though Monica's not moving during that time, we want to include that in the total time. And then that 3.25 hours that it takes from Indianapolis to St. Louis. Now, we can't add quantities that have different units, and so we need to convert, and I'm going to convert those minutes into hours. And now that I have all my units matching, I can add together all that time in the denominator to find that it takes 5.83 hours. Using my calculator, I find that the average velocity for the entire trip is 95.3 kilometers per hour. And again, I have to have that direction of west on there to have a complete answer. The final portion of this problem asks about a return trip that's using the same route and taking the same amount of time. And we want to find the average velocity in kilometers per hour for the there and back trip. So for the entire trip, starting and ending in Cincinnati. Again, focusing on that equation, average velocity is displacement over time. And we're going to pay attention to the fact that displacement is the final position minus the initial position. In this case, the final position and the initial position are the exact same. Both are in Cincinnati. Therefore, my displacement would be 0, meaning that my average velocity is also 0. Again, remember, as we discussed in class, a 0 displacement, or in this case, a 0 average velocity, does not mean your object didn't move. It just tells me that the initial point and the final point are in the same location. We will, of course, do lots more practice with these equations and concepts in class.